Hello everyone. Thanks for joining us today. My name is Patrick Hall. I will be the presenter of this session covering Texas Instruments Bluetooth Low Energy technology and how to get started with it. This is the agenda. First, we'll have a brief look at the fundamentals of the technology. We will look at the capabilities, limitations, and the typical use cases for Bluetooth Low Energy. I will then demonstrate the SenseTi sensor tag development kit using Bluetooth Low Energy out of the box to transfer sensor data to an iPad. Then we will dive into the essential part of this session, namely getting started with TI Bluetooth Low Energy. Here I will explain how to get started with Bluetooth Low Energy using the solutions offered by TI. I will describe the kits, the hardware, and the software. We will then take a closer look at the CC2541 Mini Development Kit. You will walk away from this session with a complete overview of TI solutions, how to get it, how to use it, and how to move forward. Bluetooth Low Energy is the most exciting wireless communications technology right now. The technology reinvents interoperability within a wide range of market segments ranging from industrial automotion to home entertainment. TI was first to release a single-node Bluetooth low-energy solution. We are the leading semiconductor company providing the most mature, flexible, and complete solution on the market right now. Bluetooth Low Energy is part of Bluetooth version 4 and is not compatible with classic Bluetooth. Bluetooth Low Energy is designed as a wireless personal area network with star topology. The range can be extended to hundreds of meters. The star topology means that a master, for instance an iPhone, can be connected to multiple slaves, for instance heart rate straps. A slave can only be connected to one master. Bluetooth Low Energy is targeted towards wireless applications with low power, low latency, and low throughput requirements. Low power means that a product can run for years on a single coin cell battery. Low latency means response times are down to milliseconds. This comes at the cost of throughput, which is limited to a few kilobytes per second. The technology is primarily centered around the mobile phone, tablet, and PC ecosystem, but is also well suited for other applications. There is ongoing development in many market segments, and only the future will tell where Bluetooth Low Energy will grow the most. To make the Bluetooth ecosystem easier to grasp, the Bluetooth Special Interest Group, also called Bluetooth SIG, has grouped the products into 3 brand categories: Bluetooth Smart, Bluetooth Smart Ready, and Bluetooth Classic. Bluetooth Classic is the Bluetooth that you know today. Bluetooth Smart is the low power accessory like a heart rate strap or a health thermometer. As mentioned, Bluetooth Low Energy is not compatible with Bluetooth Classic. In the middle, we have Bluetooth Smart Ready, a brand for devices that can communicate with Bluetooth Classic and Bluetooth Smart. This would typically be a smartphone, tablet, or PC. TI offers products in all the mentioned categories. Bluetooth Low Energy operates in the unlicensed 2.4 GHz band together with Wi-Fi, Bluetooth Classic, Zigbee, and others. Bluetooth Low Energy uses 40 radio frequency channels. There are 2 types of BLE channels: advertising and data channels. Advertising is done on the 3 physical channels shown in red. These channels have been chosen to minimize overlap with the most commonly used Wi-Fi channels. The advertising channels are used to discover devices, establish connections, and for broadcasting messages, whereas data channels are used for bidirectional communication between connected devices. A frequency hopping mechanism is used in order to avoid possible interference and wireless propagation issues such as fading and multipath. The fact that Bluetooth Low Energy can run on a single coin cell battery for more than a year is one of the key benefits of the technology. This is mainly because of a shortened package format and overhead, which means that the throughput is lower for Bluetooth Low Energy compared to Bluetooth Classic and Wi-Fi. All communication between two connected devices occur on connection events. These connection events occur periodically with a configurable connection interval ranging from 7.5 milliseconds to 4 seconds. Each event occurs on one of the 37 data channels, and the master always initiates the event, with the slave listening. They can continue to communicate back and forth as much as they want during one connection event. Connection events occur even if neither side has data to send. This ensures that the link is still valid. If a specified number of connection events occur without acknowledgement, the connection will be considered lost. The illustration shown is based on a real measurement of current draw. As you can see, the device spends a lot of time in sleep, where the current consumption is around 1 UA. This is one of the main reasons why Bluetooth Low Energy is low power. In the zoomed in part, you can also see the power profile when a slave device wakes up, does some processing, listens for the master, sends an acknowledgement, and goes back into sleep after some post-processing. A Bluetooth Low Energy device can operate in 4 device roles. The ones used for connections are the peripheral and central roles. A peripheral device is an advertiser that is connectable and can operate as a slave in a connection. This could, for example, be a health thermometer or a heart rate sensor. A central device scans for advertisers and can initiate connections. It operates as a master in one or more connections. Good examples are smartphones and computers. A broadcaster is a non-connectable advertiser. For example, a temperature sensor that broadcasts the current temperature or an electronic locationing tag. An observer scans for advertisements but cannot initiate connections. This could be a temperature display that receives temperature data and presents it. Also note that a device can operate in multiple roles simultaneously. Bluetooth Low Energy is designed for data sharing. To ensure interoperability, Bluetooth SIG has developed a set of application-specific profiles. A profile defines and describes the use of services necessary to implement a given application. One example is the heart rate profile, developed and adopted by Bluetooth SIG and its members. This means that a Bluetooth Smart Ready device, such as a smartphone, can work with Bluetooth Smart Heart Rate sensors from different vendors. As the illustration shows, a profile is composed of one or more services with associated characteristics. For a heart rate sensor, the profile would consist of a heart rate service with measurement as the associated characteristic. In the example, the measurement shows a heart rate of 98. In addition, the heart rate profile also includes the device information service, which provides information about the device, for example, system ID. Note that both of these adopted services include several other mandatory characteristics, even though they are not shown in the example. There are 2 different types of profiles: the profiles adopted by Bluetooth SIG and proprietary profiles. Bluetooth SIG has adopted profiles such as proximity and find me. The proximity profile has services as link loss and immediate alert. As you can see, several profiles may implement the same type of services. In this example, the immediate alert service is used by both the proximity and find me profiles. Proprietary profiles are user-specific profiles such as the TI sensor tag services, which we will see later. The generic attribute profile, or GATT, is the architecture that specifies the structure in which data is stored and exchanged. Servers have data exposed via services that contain characteristics. Clients can decide to access this data. The client uses a set of GATT protocol requests or commands towards the server to access the data. Going back to the heart rate sensor example, the smartphone would be the client and the heart rate sensor would be the server providing the measured heart rate. The client and server roles of a device are independent of the device's central and peripheral roles. It is possible for a device to act as both a client and a server simultaneously, although the server on one device is independent of the server on the other. To summarize then, GATT encapsulates the data in services and exposes them by the characteristics as we saw earlier. The sensor tag is one of TI's latest and most popular development kits. I will now show how easily a Bluetooth Low Energy sensor tag connects to an Apple iPad and obtains sensor data over the air from 6 different sensors. The sensor tag kit includes the sensor tag board, which is populated by CC2541 buttons, LEDs, and 6 sensors to measure acceleration, rotation, pressure, humidity, magnetic field, and object temperature. All sensors are individually configurable from the iPad or iPhone. The sensor tag runs on a single CR2032 coin cell battery. The sensor tag can, after the battery is inserted, be connected to compatible iOS device right away. This requires the TI BLE Multitool app to be downloaded from the App Store. Once the sensor tag has been connected to the iOS device, all sensor data is dynamically updated. We will now show a short video introducing you to the sensor tag application.
I am Marianne Styrman and I'm going to show you the sensor tag today. This beauty is only $25 and we have added 6 sensors to it. We have also created a very useful app for you, allowing you to get quickly up to speed and create your prototype. But let's get started and show you how it works. First, you download the sensor tag app and you connect the sensor tag, and it's loading the information from all the sensors. Here you see the 6 sensors: accelerometer, magnetometer, gyroscope, air temperature, barometer and humidity. By shaking the sensor tag, you can see the readings change. I brought my favorite coffee cup to demo the TI temperature sensor. This measures the temperature of the coffee. The coffee can also demo the humidity sensor. Our app will give you graphs of the sensor readings. I want to show you the profile screen. Let's pretend we're doing an air mouse, leaving only the gyroscope, magnetometer, accelerometer. I'm changing the update interval of the accelerometer to 100. And now, if you see the graph, you see it changes very quickly. The source code of the app is free, and if you want to make your own app, in this case, the air mouse, you can generate the source code and email it to yourself. I also want to highlight the very important over-the-air download. This ensures your end products are up to date by allowing it to be upgraded directly from the smartphone app. So now I showed it to you and I told you it was quick and easy. It's really good. To find out more information, please visit the ti.com/sensortag and you will find all the information you need to get started. Thank you!